You are welcome to my YouTube channel. Our topic today is the Diophantine equation. We'll begin with a definition. An equation is called Diophantine if we are only concerned with its integer solutions. For example, ax plus by is equal to c, where a, b, and c are fixed integers and xy are integer variables, is a linear Diophantine equation in two variables. Theorem: let a and b be integers with d equal to the greatest common divisor of a and b. The equation ax plus by equal to c has no integral solutions if d does not divide c. But if d divides c, then there are infinitely many integral solutions. Moreover, if x0, y0 is a particular solution of the equation, then all solutions are given by x equal to x0 plus b over dn and y equal to y0 minus a over dn, where n is an integer. The proof of this theorem is left as an easy exercise. Example: find the general solution of the linear Diophantine equation. 60x plus 33y equal to 9. Solution: we will find all solutions to 60x plus 33y equal to 9. First, we compute the greatest common divisor of 60 and 33. And if you do that properly, the answer will be 3. And since 3 divides 9, the equation has a solution. Moving forward, you say using the Euclidean algorithm, 60 will be equal to 1 times 33 plus 27. 33 will be equal to 1 times 27 plus 6, while 27 will be equal to 4 times 6 plus 3, and 6 is equal to 2 times 3 plus 0. This is how to use the Euclidean algorithm to find the greatest common divisor of 60 and 33. Okay, we have shown that the GCD is 30. Now, using the back substitution method or the modified Euclidean method, 3 will be equal to 27 minus 4 times 6, and it will continue down to 5 times 60 minus 9 times 33, which will give us the linear combination of 60 and 33. Thus, one particular solution is x0 will be equal to 5 times 9 all over 3 equal to 15. And y0 will be equal to minus 9 times 9 over 3, which is minus 27. Therefore, the general solution is given by the theorem x equal to 15 plus 11y, and y will be equal to minus 27 minus 20n, where n is an integer. Let's look at some application of the Diophantine equation in two variables. An example: Clara wants to buy pizza and cola for her family. She has 400 naira. If each pizza costs 57 naira and each bottle of cola costs 22 naira, how many pizzas and bottles of cola can she buy? Solution: let x and y represent pizza and cola respectively. We set up the equation as a linear Diophantine equation, and it will turn out to be 57x plus 22y equal to 400. Using the Euclidean algorithm to compute the greatest common divisor of 57 and 22, we'll discover that their GCD will be 1, and 1 actually divides 400, according to our theorem. So there are infinitely many solutions to the problem. Using the extended Euclidean algorithm, 1 will be equal to 9 minus 4 times 2, and that will take us down to 13 times 22 minus 5 times 57. So multiplying by 400 will now give us 400 will be equal to 13 times 400 times 22 minus 5 times 400 times 57. Thus, a particular solution is our x0 will be minus 2000 and our y0 will be 5200. Therefore, the general solution will be, according to the theorem, that x will be equal to minus 2000 plus 22n and y will be equal to 5200 minus 57n. Now, since x and y represent the number of pizzas and bottles of cola, they must be non-negative, because negative numbers here will make no meaning to us. Therefore, when you look at the equations and try to find n will give us less than or equal to 91 or greater than or equal to 90. Now, the integer that will satisfy both conditions will be when n is 91. Therefore, in that case, when you substitute n to be 91 in the equations above, our s will be equal to 2 and our y will be equal to 13. So Clara can buy 2 pizzas and 13 bottles of cola. Our next example, find the solution of 155x plus 45y equal to 7. First, we must find the greatest common divisor of 155 and 45. And the answer is 5. Now, since 5 and 7 are relatively prime, 5 does not divide 7. Therefore, there is no solution to the given equation, according to our theorem. Let's look at Diophantine equations with more than 2 variables. Theorem: if a1, a2, down to an are non-zero positive integers, then the equation a1x1 plus a2x2 plus ... plus anxn will be equal to c has an integral solution if and only if g is equal to the GCD of a1, a2, down to an divide c. Furthermore, when there is a solution, there are infinitely many solutions. The proof of this theorem is left as an easy exercise. We'll have another example. In this case, we have more than 2 variables to work on. Peter wants to buy pets. He has 151 euros and he must choose at least one of each pet. The prices are fishes, 3 euros each, cats, 5 euros each, dogs, 10 euros each. How many fishes, cats, and dogs can he buy? Solution: the equation is 3x plus 5y plus 10z equal to 151. Using the method as in previous example, we rewrite it as 3x plus 5y plus 10z equal to 151. We'll continue. We'll say let v equal to 3x plus 5y. So the equation will now reduce to v plus 10z equal to 151. The general solution will now be that v equal to 151 plus 10t, where our z is equal to minus t. Substituting v equal to 3x plus 5y, we get 3x plus 5y equal to 151 plus 10t. Solving for x and y, we will obtain that our x will be 47 plus 5k and our y will be 2 plus 2t minus 3k, where t and k are integers. Since x, y, z must be at least 1, we find the valid ranges. Okay, the first one is 47 plus 5k must be greater than 0. Second one is 2 plus 2t minus 3k must be greater than 0. And minus t must be greater than 0. Solving these inequalities, we determine k must take ranges from minus 10 to 0, and t will take values from minus 16 to minus 1. Setting t to be equal to minus 14, we get that k will be minus 9. And substituting, we are going to arrive at x equal to 2 and y equal to 1, yz will be equal to 14. Therefore, Peter can buy 2 fishes, 1 cat, and 14 dogs with his 151 euros. To count the number of solutions, we use theorem 2, which means that since m is 10 and d is 1, and there are 2 variables, the number of incongruous solutions will be 10. Thus, there are 10 different ways for Peter to buy the pets. Thank you for watching.